This video is going to look at extending our understanding of logarithms and develop some properties as we go along here. So first, we just want to look at these expressions, and I've given one logarithmic expression, but I want to look and see what these properties are in terms of their log form. So if I look at b to the 0 is equal to 1 as an exponential, if I convert that to a logarithm, that would be log base b log base b of 1 is equal to 0. Log base b of 1 is equal to 0. So this means if you're working with a logarithm of any particular base and the input is 1, you get out 0. Oh, okay, that's kind of handy. So that we should definitely keep in our toolkit. Okay, b to the first is equal to b. Well, it's kind of like duh. What would this be in log form? So it'd be log, circle the base, of b, log base b of b is equal to 1. Okay, well, and that's kind of like a duh thing too. Um, these, you don't really want to say cancel out, but if the base matches the input, the output's just 1. B to the x is equal to b to the x. Okay, so now this is going to be a little weird, but I'd say, okay, let's circle the base. This would be log base b of b to the x of b to the power of x is equal to x. Okay, more on this in a later video series, but yeah, if we have log base b to the b of b to the x, we just get out x. Similar thing here, so that I'd circle the, um, so here I'd maybe want to convert this to exponential. So convert this from log form to exponential form. So I'd have b to the power of log base b of x is equal to x. Is equal to x. Okay, so a base and a logarithm cancel each other out is kind of what these last two are saying. These four things are very useful properties for logarithms to have in our back pocket. Okay, it helps us simplify our work. Okay, and so now previously we mentioned on the way to talking about logarithms that logarithms were a way to undo an exponential, a way to find the inverse function for an exponential function, because after all, an exponential function is one-to-one, it passes the horizontal line test, so it should have an inverse function. Okay, and so we, because of the inverse property that logarithms carry with exponential functions, we can remember that something happens with the domain and range. In particular, the domain of the original becomes the range of the inverse. So if the domain of an exponential function is all real numbers, that's the range of a logarithm. And if the range of the exponential is 0 to infinity, then that becomes the domain of a logarithm. Okay? And then similarly, because we switch domain and range, the asymptote changes. So horizontal asymptote of y equals 0 occurs for exponential functions. That becomes a vertical asymptote at x is equal to 0. And we can actually see that line up from the domain, right? We can't have anything before 0. So that's where the asymptote comes into play. Okay, and then similarly, exponential function, we know it's increasing on its entire domain, and actually that carries forward with logarithms. So we would say logs, if it has, so for logarithms, if it has a base that is larger than 1, then it increases. And similarly, if the base value, so this is, a fraction between 0 and 1, if we were dealing with exponential functions, we would say that the function is decreasing on its entire domain. Actually, the same thing happens with logs as well. Okay, so we would see decreasing behavior. Okay, so now, I want to talk about domain here for a minute because it is important for logarithms since we have a restriction, right? We have the domain has to be from 0 to infinity. Now that is truly for just log base b of x. So what we would do in general to find the domain is we would take whatever our input is, so 3x plus 4, or minus 4, so whatever this is in here, that has to be greater than or equal to 0. So I'd take that and set that greater than or equal to 0 and solve. Okay, so move the 4 over. 3x is greater than 4. X is greater than 4/3. That becomes my domain. Okay, so I'm going to say that the domain for function f here is going to be 4/3 with a parentheses off to infinity. Okay, and similarly, the vertical asymptote is going to occur precisely when that input is equal to 0, or it's just the boundary of your domain. But if you solve this here, you have 3x equals 4. It's pretty much the same work. X is equal to 4/3. Okay, and that would be my vertical asymptote. So if you want to find the domain, take whatever you have inside the logarithm, right? Inside the logarithm, set that greater than 0, solve. Boom, done, you have your domain. The range is always going to be all real numbers, okay? And that's just an artifact of you having a logarithmic function. Kind of like how the exponential function domain was always all real numbers. Okay, now, some other properties of logarithmic functions is we have two special logarithms that we see frequently, actually. So we talk about common log and natural log, and common log means that it just has base 10. So if you see a logarithm that doesn't have a base, and it expresses log of x, that is assumed to be base 10. Similarly, if you instead see ln instead of log for logarithm, that just means natural log, and so you have a base of e for that, the natural number e. So this is, the number that's approximately like 2.71-ish. Okay, so be on the lookout for those two logarithms, and maybe we can make use of these in our work. So if we want to find the value of each of these, okay, what we can do, kind of do what we saw before, so natural log of e to the 5th, okay? You might already know that this is 5, but let's pretend we don't know. Let's set it equal to x, and then switch it from logarithmic form to exponential. So again, if you want to write it as log base e, right? You certainly can. And then you can convert it. You could say e to the 5th is equal to e, or e to the x, sorry, e to the x is equal to e to the 5th, and then x is equal to 5. Or if you are a clever person, you don't need that anymore, right? You can use that log property from above that says, oh, you have the base of the logarithm matching the base of the exponent, so it's just 5. So you can just say 5 is equal to x, okay? In the same vein, I'm going to let you do this out, but this one should equal -3, okay? So try that on your own, and if you have questions, let me know. But point of all this is logarithms carry a lot of properties with them. Certainly we have common and natural logs to talk about, but we can also talk about the domain of a logarithmic function, right? And vertical asymptotes. And then certainly domain and range and asymptotes with that. But then more importantly is kind of just these algebraic relationships that we need to have under our command. So be on the lookout for these. Make sure you get these in your notes, and we'll see more on logarithmic functions in the next video.